Hey, space explorers. Are you ready for another amazing journey into the mysteries of the universe? We're back with part 4 of our series, and this time we're diving even deeper into space to explore some of the weirdest and wildest things out there. We'll be uncovering secrets about the cosmos that will blow your mind. So buckle up and get ready to explore the incredible wonders that lie beyond our planet. It's going to be an out-of-this-world adventure. The Great Silence. The puzzling Fermi paradox. Imagine you're at a giant playground filled with swings, slides, and monkey bars. You expect to see lots of kids playing, but as you look around, you realize you're all alone. That's kind of what scientists feel like when they think about the Fermi paradox. The paradox, where is everyone? The universe is mind-bogglingly huge. It's filled with billions of galaxies, each with billions of stars. And scientists think many of those stars have planets orbiting them, just like our solar system. Some of these planets might even be like Earth, with the right conditions for life to exist. So if the universe is so big and there are so many potential places for life, why haven't we found any aliens yet? That's the big question at the heart of the Fermi paradox. It's a paradox because there seems to be a huge contradiction between the high probability of alien life and the complete lack of evidence we have for it. The clues and the missing pieces. Scientists have been searching for signs of extraterrestrial life for decades. They've sent spacecraft to explore other planets, listened for radio signals from distant stars, and even searched for traces of alien technology in our solar system. But so far, they haven't found anything. This silence is a puzzle. If intelligent life is common in the universe, you'd think that at least some of them would have developed advanced technology and ventured out into space. Maybe they would have visited Earth or sent us messages, but we haven't heard a peep. Possible explanations. We're alone. It's possible that life is incredibly rare, and we're the only ones out there. This is a lonely thought, but it's a possibility. They're hiding. Maybe aliens are out there, but they're hiding from us for some reason. Maybe they're too advanced and we're like ants to them, or maybe they're scared of us. They're different. Perhaps alien life is so different from us that we haven't been able to recognize it. Maybe they communicate in ways we can't understand, or they live in environments that we wouldn't even think to look for. The search continues. Despite the lack of evidence, scientists aren't giving up on finding alien life. They're building even more powerful telescopes, sending more spacecraft to explore other planets, and developing new ways to search for signs of life. The Fermi paradox is a reminder of how much we still don't know about the universe. It's a mystery that pushes us to explore, to innovate, and to imagine the possibilities of what might be out there. So keep your eyes on the sky, and who knows, maybe one day we'll finally hear a friendly hello from another planet. The incredible shrinking universe. The mystery of quantum gravity. Imagine a world where the rules are completely different for big things and small things. For example, imagine that elephants can fly, but ants can't. That's kind of how it is with gravity. We know how it works for big things like planets and stars, but when it comes to tiny particles, the rules get really weird. The big and small problem. Scientists have 2 super important rule books to explain how things work in the universe. Einstein's general relativity. This book tells us about gravity and how it works for big things like planets, stars, and galaxies. It says that gravity is caused by the bending of space and time, like a bowling ball sitting on a trampoline. Quantum mechanics. This book is all about the tiny world of atoms and particles. It has some really strange rules, like particles being in multiple places at once and talking to each other faster than the speed of light. The clash of the titans. The problem is that these 2 rule books don't seem to agree with each other. Einstein's general relativity works great for big things, but it breaks down when we try to apply it to the tiny world of quantum mechanics. And the rules of quantum mechanics don't seem to explain how gravity works at all. This is where quantum gravity comes in. Scientists are trying to come up with a new rule book that combines the best of both worlds. A theory that can explain how gravity works for both big things and small things. The search for a theory of everything. Scientists call this quest for a new rule book the search for a theory of everything. It's like trying to find a master key that can unlock all the secrets of the universe. This theory would explain all the fundamental forces of nature, including gravity, in one elegant package. But finding this theory is not easy. It's like trying to put together a giant jigsaw puzzle with pieces that don't quite fit together. Scientists are working hard to find the missing pieces and make all the rules fit together perfectly. Why does it matter? Understanding quantum gravity is important because it could help us answer some of the biggest questions about the universe. What happened at the Big Bang? The Big Bang is the event that started our universe, but our current theories break down when we try to understand what happened at the very beginning. Quantum gravity might give us the tools to look back to the first moments of the universe. What's inside a black hole? Black holes are regions of space where gravity is so strong that nothing can escape, not even light. Quantum gravity could help us understand what's happening inside these mysterious objects. The future of the universe. By understanding quantum gravity, we might be able to predict the ultimate fate of the universe. Will it expand forever? Or will it eventually collapse in on itself? The quest for quantum gravity. The search for quantum gravity is one of the most exciting and challenging frontiers of modern science. It's a quest that pushes the boundaries of our understanding and requires us to think in new and creative ways. Who knows what amazing discoveries we'll make along the way? The wow signal, a cosmic hello or a galactic glitch. Imagine you're listening to the radio, scanning through static and white noise, when suddenly a clear, strong signal pops up. It's a moment of excitement, wondering if it's a message from someone far away. In 1977, astronomer Jerry Ayman had a similar experience when he was searching for alien signals from space. But instead of music, he heard a mysterious radio signal so interesting he wrote "wow" next to it on the printout. That's how the wow signal got its name. What was the wow signal? The wow signal was a super strong radio signal that lasted for 72 seconds. It came from the direction of the Sagittarius constellation, which is a group of stars that looks kind of like a teapot. But here's the thing. Scientists couldn't explain where it came from. It was unlike any natural radio signals they had ever heard before. The mysterious origins. For years, scientists puzzled over the wow signal. Was it a message from aliens trying to contact us? Or was it something else, like a natural phenomenon that we just didn't understand yet? Some scientists thought it could be a glitch in the telescope's equipment, but that didn't seem likely. The signal was too strong and clear to be a simple mistake. Others wondered if it could be a secret military transmission or a signal from a satellite. But none of those explanations really fit. Could it be aliens? The possibility of the wow signal being a message from aliens was exciting. If it were true, it would be one of the most important discoveries in human history. But scientists couldn't find any other signals from the same direction, and they couldn't repeat the observation. It was like hearing a single word in a foreign language but not understanding anything else around it. A comet connection? Recently, some scientists have suggested a new explanation for the wow signal. They think it might have come from a comet that was passing through that part of the sky in 1977. Comets release hydrogen gas, which can emit radio waves at the same frequency as the wow signal. However, not everyone agrees with this explanation. Some scientists argue that comets don't produce strong enough radio signals to account for the wow signal. The mystery continues, and scientists are still searching for answers. The wow signal's legacy. Even though we might never know for sure what caused the wow signal, it remains one of the most intriguing and mysterious events in the history of astronomy. It reminds us that the universe is vast and full of surprises. The wow signal also highlights the importance of the search for extraterrestrial intelligence, SETI. By listening for signals from space, we might one day find evidence of other civilizations out there. Who knows? Maybe there's another alien out there listening to our radio signals right now and saying, "Wow, the brightest beacons in the universe, the mysterious quasars." Imagine a giant cosmic flashlight shining brighter than 1,000,000,000,000 suns. That's a quasar, one of the most powerful and mysterious objects in the universe. They're like giant lighthouses in space, beaming out incredible amounts of energy that we can detect even from billions of light years away. What makes a quasar shine so bright? Quasars aren't actually stars, even though they look like them when we see them through telescopes. They're thought to be powered by supermassive black holes, which are black holes millions or even billions of times more massive than our sun. These monster black holes have a huge appetite and love to eat up all the gas and dust around them. As this stuff swirls around the black hole like water going down a drain, it gets heated up and emits an enormous amount of energy, including bright beams of light and other radiation. This is what we see as a quasar. Why are quasars important? Quasars are like giant telescopes in space, allowing us to look back in time. Since their light takes billions of years to reach us, we're actually seeing them as they were billions of years ago when the universe was much younger. This helps us understand how galaxies and black holes formed and evolved. Quasars also help us map out the universe. By studying their distances and positions, we can learn more about the structure and expansion of the universe. It's like using lighthouses to guide ships at sea, except these lighthouses are billions of light years away. The mystery of quasar activity. One of the biggest mysteries about quasars is why they're so active. Most galaxies have supermassive black holes at their centers, but not all of them have quasars. So what triggers these black holes to start gobbling up so much matter and creating these dazzling displays of energy? Scientists think it might have something to do with collisions between galaxies. When two galaxies collide, it could cause a sudden influx of gas and dust into the central black hole, fueling its activity and creating a quasar. The future of quasar research. Scientists are using powerful telescopes like the James Webb Space Telescope to study quasars in more detail. They're hoping to learn more about their structure, their energy sources, and how they impact the galaxies they live in. The study of quasars is a fascinating adventure that takes us to the very edge of the observable universe. With each new discovery, we gain a deeper understanding of these incredible objects and their role in the cosmic symphony of the universe. So next time you see a bright light in the night sky, it might not be a star at all, but a distant quasar, shining its beacon across billions of light years to reach us. The messy universe, the puzzle of the entropy. Paradox. Imagine your bedroom. If you don't clean it up, it naturally gets messier and messier over time. Toys get scattered, clothes pile up, and things generally get more chaotic. Scientists call this kind of messiness entropy. And there's a rule in science that says entropy always increases in the universe. It's like a cosmic rule that everything tends to get messier over time. But here's the mystery. If the universe is always getting messier, how did it start out so neat and organized in the first place? The Big Bang, the event that kick-started our universe, is thought to have begun with a very low level of entropy, meaning everything was neatly packed together. How did we go from a tidy universe to a messy one? That's the puzzle of the entropy paradox. A cosmic cleanup crew? One way to think about the entropy paradox is like a giant cosmic cleanup crew. If your room always gets messier, it means someone or something must be tidying it up every now and then, right? Similarly, some scientists have proposed that maybe there's a force or mechanism in the universe that counteracts the increase in entropy, keeping things from getting too chaotic. The arrow of time, one-way street. Another clue to this mystery is the arrow of time. You know how time always moves forward? You can remember yesterday, but you can't go back and change it. Well, the arrow of time is linked to the idea that entropy always increases. As things get messier, time moves forward. But if the universe started out tidy, how did the arrow of time begin? The quantum world's role. Scientists are also exploring the world of tiny particles, called the quantum world, to see if it might hold answers to the entropy paradox. In the quantum world, things can get really weird, with particles popping in and out of existence and even being in multiple places at once. Some scientists think that these quantum weirdness might play a role in the entropy paradox, but we're still figuring it all out. Why does it matter? The entropy paradox is a big deal for scientists because it challenges our understanding of how the universe works. If we can solve this mystery, we might learn more about the fundamental laws of physics, the nature of time, and even the origin of the universe itself. It's like trying to solve a giant puzzle. Each piece we find, like the arrow of time or the quantum world, brings us closer to the complete picture. And who knows, maybe one day, you'll be the one to help solve the entropy paradox and reveal a whole new understanding of the universe. The quantum world, where things get super weird. Imagine a world where cats can be both alive and dead at the same time. Particles can disappear and reappear in different places. And tiny things seem to know what you're thinking before you even think it. Sounds crazy, right? Well, that's the strange and wonderful world of quantum physics, where things get super weird. What is quantum weirdness? Quantum physics is a branch of science that studies the tiniest things in the universe, like atoms and the even smaller particles that make them up. And it turns out, the world of the very small is very different from the world we see around us. In the quantum world, things don't always follow the same rules as big objects like cars, balls, or even ourselves. Things get fuzzy and uncertain. It's like trying to play a game where the rules keep changing, making it really hard to predict what's going to happen next. Superposition, being in two places at once. One of the weirdest things about quantum physics is something called superposition. It means that tiny particles can be in multiple places at the same time. It's like being able to sit in two different chairs at once, or being both awake and asleep at the same time. Scientists have even done experiments where they've shown that a single particle can go through two different slits in a wall at the same time, creating a pattern on the other side that can only be explained if it was in two places at once. Entanglement, spooky action at a distance. Another spooky thing about quantum physics is entanglement. This is when two particles become linked together in a special way, even if they're miles apart. If you do something to one particle, the other one will react instantly, like they're talking to each other without using a phone or anything. Einstein called this spooky action at a distance, and even he was puzzled by it. It's like having a twin who can always tell what you're feeling, no matter how far away they are. Why is quantum weirdness important? Even though quantum physics seems like it's from a science fiction movie, it's actually very important. It's helping us understand how the universe works at its most fundamental level, and it's leading to the development of new technologies like super-fast computers and incredibly accurate clocks. Quantum weirdness is still a big mystery, and scientists are still trying to figure out all the rules. But it's a super exciting field of research that could lead to some amazing discoveries in the future. The greatest mystery: how did life begin? Imagine a world without any animals, plants, or even tiny bugs. It would be a pretty boring place, right? But that's what Earth was like billions of years ago, a lifeless rock floating in space. So, how did life start? It's one of the biggest mysteries scientists are still trying to solve: the building blocks of life. First things first, what is life? We know living things grow, eat, and make copies of themselves. But all living things are also made up of special building blocks called molecules. These molecules, like proteins and DNA, are like the instructions for how to build and run a living thing. Scientists think that the very first life on Earth was probably very simple, maybe just tiny organisms floating in the ocean. But even these simple creatures needed the right ingredients to come together and form. The primordial soup. Imagine a warm, shallow pool of water filled with all sorts of chemicals. Scientists think this is where life might have first started, in a kind of primordial soup. The energy from lightning or the sun could have caused these chemicals to react and form the building blocks of life. But how did those building blocks come together to make the first living cells? That's the big question, the RNA world. Some scientists think that a molecule called RNA might have been the first step. RNA is kind of like DNA's simpler cousin. It can store information like DNA, but it can also act like a tiny machine, helping to build other molecules. So maybe there was a time when RNA was the main player in the game of life, creating more of itself and eventually leading to the development of more complex life forms. The search for clues. Scientists are searching for clues about the origins of life in many different places. They're studying ancient rocks on Earth, looking for signs of the first living things. They're also exploring extreme environments like deep-sea vents and hot springs, where some of the most ancient organisms on Earth still live. Some scientists are even looking beyond Earth, searching for signs of life on other planets and moons. If we can find life elsewhere in the universe, it could give us clues about how life began on our own planet. The mystery continues. The question of how life began is one of the most exciting and challenging mysteries in science. There are many theories, but we still don't have a definitive answer. But that's what makes science so much fun. We're always learning new things and exploring new ideas, so keep asking questions, stay curious, and who knows? Maybe one day, you'll be the scientist who helps unlock the secrets of how life began on Earth. The more we learn, the more questions we have. So keep asking questions, keep exploring, and who knows what amazing discoveries you'll make. The universe is your playground, and the adventure is just beginning. Please hit like button, comments, and share the video. And do not forget to subscribe for more videos.